ground speed out 350 knots, ground speed home 250 knots. Distance from A to B is given. What is the distance and time to point of equal time from A? Now here you have to use normal formula, put the values and get the figures. So get the answer. So here we are going to use ground speed on for outbound ground speed home. So distance to critical point equals to total distance multiplied by homebound speed divided by outbound plus homebound. So total distance is 1200. Homebound speed is how much? 250 divided by 250 plus 300. So 250 plus 300 equals to 550. 1200 multiplied by 250 equals to 30000. So distance to critical point equals to this much divided by 550, which is 545 nautical miles. Time to CP will be distance to critical point divided by outbound speed. So 545 outbound speed is 300. That is 1 hour 49 minutes. 1 hour 49 minutes. So the closest option here is 545 nautical miles. So you have 545 here, 545 here, and the time is 1 hour 49. So the correct option is option delta. Option delta. So question 7. Two engine task 450, one engine task 350. Distance from point A to B, tailwind component of 50. What is the distance and time to CP? So again, this is your point A, this is your point B. Okay. This is your critical point where you will make a decision whether to continue to your destination with one engine failure or come back to your departure with one engine failure. So you are getting a 50 knot ka tailwind going outbound, and the same wind component will become your headwind coming homebound. So it's just a matter of perspective. So two engine task is 450 knots. Two engine task is 450 knots. That means flying from A to critical point. Up to critical point, everything was working fine. Okay. So you were flying at a task, normal task of 450 knots. But at critical point, at this critical point, you experience engine failure. You experience engine failure. So now the speed of your aircraft will be TAS 350, reduced speed. So TAS will be reduced 350. So now you are going to make a decision whether to continue to your destination or come back to your departure. Either way, the time is going to remain the same. The time you will require to go to the destination or to come back to your departure is going to remain the same. So if you continue, if you choose to continue to your destination, if you choose to continue to your destination, in that case, you will be flying with a ground speed of 350, a new speed, 350 knots, that is engine failure task speed plus 50 because you are getting a tailwind. So ground speed will be task plus tailwind. So that will be 350 plus 50, 400. If you choose to come back with that engine failure task speed, your homebound ground speed will be your task, which is 350 minus 50, which is 300, because coming back you will be getting a headwind. So now use the formula. Distance to critical point is total distance into h divided by O plus h. So total distance is 3000. Homebound speed is 300. divided by 300 plus outbound speed is 400. So 700 denominator, 3 2 is a 9 and 1 2. So this is 1285.7, 1286 nautical mile. So 1286, we have option A and delta. Time, distance to critical point divided by outbound speed. So 1286 divided by outbound speed 400 is 3 hours 12 minutes. So option A is the correct option. 8. Two engine tasks, one engine task, winds, A to B distance, course given. So now here we will have to find ground speed using your CX3. Direct wind component is not given to us. But otherwise the logic, the concept remains the same. Point A, point B, critical point, winds coming from 330 at 80, course 200. A to B course is 200. So B to A reciprocal course will be 0, 200, 180, that is 020. Winds are coming from 330 at 80 knots. So somewhat like this. Winds are coming from 330 at 80. Your aircraft is working perfectly fine, functioning perfectly fine as you go from A to this critical point. At a task, at a normal task of 480 knots. At this critical point, you experience engine failure. You experience engine failure. So now you have to make a decision whether to continue to your destination or come back from there. If you choose to continue to your destination, if you choose to continue to your destination, you will be flying at a reduced task of 400 knots, a reduced task of 400 knots. Okay. If you choose to come back, again you will be flying at a reduced task of 400 knots. Engine failure task of 400 knots. Now we have to find ground speed outbound from critical point to your destination, ground speed homebound. So let's use CX3. So outbound task is 400 knots. Course is 200. Winds are 330 at 80. So ground speed will be 446.7 or 447 knots. Ground speed homebound will be new task will be 400. True course will be 020. Wind speed 80, winds 330. So ground speed will be 343.85 or 344 knots. 344 knots. Now let's use the formula. Distance to critical point is DHO plus H. So total distance is 3500 multiplied by homebound 344 divided by 344 plus outbound 447. So 344 plus 447 is 791. 3500 multiplied by 344 is 1204. Yes. So 1522 nautical miles. Time to CP is distance to CP divided by outbound speed. So 1522 divided by outbound speed of 447, which is 3 hours 24 minutes. So the closest option 1522 and 3 hours 24 minutes. Okay, so option A. Question 9. Pressure altitude is given, temperature is given, winds given, A to B distance, course, endurance given, calibrated airspeed is given. What is the distance to the point of equal time? So A to B, total distance is 350 miles. Critical point in the center, right? Winds are 32, course is 350. Winds will be coming from 320. Yeah. So 320 at 40 knots. So this is done, this done, this done. Next, course is 350. So reciprocal course will be 170. Now we have to find TAS. True airspeed is how much? So let's first find true airspeed. True airspeed can be calculated using pressure, altitude, temperature, and calibrated airspeed. Now pressure altitude is 9,000 feet. At 9,000 feet, your ISA temperature must be 15 minus 2 into 9, 15 minus 18 minus 3. So outside air temperature is ISA minus 10. So minus 3 minus 10 is minus 13 degrees Celsius. So let's use this. Let's use this information in the airspeed option. Outside air temperature minus 13. So put 13 and then press the plus minus button. Calibrated 190 knots. Pressure altitude 9,000. Gas is 400. Temperature minus 13. Right? Minus 3, minus 13. 9,000 and 190. 9,000. Calibrated airspeed is 190. So true airspeed is, pay attention to the values that you have put, double check. 213. Let's consider 213. So 213 outbound, 213 homebound. Now let's find ground speed outbound and homebound when you put the winds in the equation. So you can use CX3 again. Outbound course 350, winds 320 at 40. So outbound ground speed is 177. Homebound, use reciprocal course 170. So ground speed is 246.38. 46. Now use the formula. Distance to critical point is dho plus h. So 350 into 246, 246. Time to CP, distance divided by outbound speed. So 203 divided by 177. 1 hour 8 minutes. So what is the distance to the point of equal time? It is 203.5. Next, given an actual time of departure of 11 hours 5 minutes. That means you are departing from this position A at 11 hours 5 minutes. What is the actual estimated time of arrival at point of equal time? So at what time will you arrive at point of equal time? So we have found time to get to critical point is 1 hour 8 minutes. That means total flight time from A to critical point is 1 hour 8 minutes. So estimated time of arrival at critical point will be 11 hours 5 minutes plus 1 hour 8 minutes. That is 12 hours 13 minutes. So option Bravo. Simple. So this concludes our lecture. I hope you have understood all the questions, the 5 questions